Hello fellas, welcome back. This next video is going to look at some double angle reducing and power reducing formulas. Again, just some more formulas to use as we're solving trig equations. So let's get those on the screen here. So here are three double angle formulas. One for sine 2u, 2 sine u, cosine u, tangent of 2u, and cosine of 2u. Cosine of 2u has a few different versions of it. You just use the one that makes the most sense. Okay, and again, this is all practice. Again, you need to know that these formulas exist. You need to know how to use them, but again, you don't need to necessarily memorize every single one of them. Okay, so let's do some examples. Here I'm giving you a triangle. 2, 5 are the opposite and adjacent sides. I'm looking for cosine of 2 theta here. Okay, so if I'm going to do that, I know the hypotenuse of that triangle is square root of 29 using the Pythagorean theorem. And now what I'm going to do is use one of my formulas to simplify this statement. Okay, I'm going to use the cosine of 2 theta is equal to 2 cosine squared theta minus 1. Once I know that, I know what cosine of theta is. Cosine of theta is adjacent over hypotenuse, or 5 over square root of 29. And then I'm going to have to square that term. Okay, and then if I simplify that down, I'm simply going to get 50 over 29 minus 1. Okay, and then I can combine and get a common denominator of 29, and I'm simply going to get 21 over 29. Okay, let's do the tangent of 2 theta. Again, I need to use a double angle theorem here. I get 2 tan theta over 1 minus tan squared theta. I know tan of theta, just opposite over adjacent, so tangent of theta is equal to 2/5. So I have 2 times 2/5 over 1 minus 2/5 squared. I'm going to get 4/5 on the top. I'm going to get 1 minus 4 over 25 on the bottom. So the bottom is going to be 21 over 25, like that. I'm going to multiply by the reciprocal, and I'm going to get 20 over 21. Okay, just to see that last step for you, let me do it out. You guys should know how to divide by fractions, but let's just do it out. If I have 4/5, then I'm going to multiply by the reciprocal of this, which is 25 over 21. That's going to be a 5. That's going to go away. That's going to be a 1. And I get 20 over 21. Okay? Let's find all solutions to the equation on the interval 0 to 2 pi. Again, I want to start by simplifying this expression right here. I'm going to get 2 sine x cosine x using my double angle equation. At this point, I can factor out a sine of x. I'm left here. And so again, I have two things multiplied together, and I get 0. Or one of them must be 0, so sine x must equal 0. Or cosine x is equal to a half. Again, I'm on 0 to 2 pi. Open interval on 2 pi side, so that 2 pi doesn't count. So for this solution, I'm going to get is 0 right there, or pi. Okay, remember that sine of 0 is pi. Sine of 0 is 0, and sine of pi is also 0. Over here, I'm looking for angles in the first and fourth quadrant. Okay, so I'm going to get pi over 3 and 5 pi over 3. Okay, so there are my 4 solutions to this equation. Again, I needed the double angle equation to simplify that particular term right there. There's some power reducing formulas. These are useful as well, fellas. If I get sine squared of u, cosine squared of u, or tan squared of u, I can use these. These are particularly important. These two right here, I would tell you these ones are critical. Make sure you're aware of them because you're going to use them in calculus quite a bit. Let's do a couple examples with those. If I want to simplify sine squared of 3x, I would just use the power reducing formula. 1 minus cosine of u over 2. Here u is 3x. So I get 1 minus cosine of 6x over 2. Okay? If I have cosine squared x times tan squared, I can substitute in for both of those. This term right here, this is my cosine squared. That's cosine squared right there. And this one right here is tan squared. And if I look at that, the this term and this term is going to cancel, and I'm going to get left with 1 minus cosine 2x over 2, which you should note is also equal to sine squared of x. And you guys should be aware that I should have got that anyways, because cosine squared times sine squared is simply, cosine squared times tan squared is equal to sine squared. Okay? Let's do one that's a little bit more complicated here. Cosine to the fourth, I'm going to use my power reducing formulas. To do that, I'm going to write that as cosine squared squared, like that. And now I can simplify the inside part of that. That's just 1 plus cosine 2x over 2. If I expand that out, what I get is this right here. I get a 1/4, take that term out. I FOIL this one out. 1 plus 2 cosine 2x plus cosine squared of 2x. So that step right there is coming from the fact that I have 1 plus cosine 2x. If I'm squaring that, I'm going to FOIL it. I get 1 plus 2 cosine squared of 2x plus cosine squared 2x, like that. Now the problem that we have here is that I still have a square term here, and I want first powers of cosine, so I have to substitute in again. And so what I'm going to do is I'm going to replace that term with 1 plus cosine 4x now, right, because it's already a 2x in there, and so the 2x becomes a 4x when I plug it into the power reducing formula. So if I make that cosine 4x over 2, I'm going to have to make that substitution for that term right there. And if I do that, I get something that's pretty long and drawn out. Well, let's just take a quick look at that here and notice that this is the initial substitution that I made. I just substituted in for that cosine squared 2x, this term right here, right there. And then what I did is I factored out a 1/2 out of everything, and that's why you see a 1/8 here. This became, when I took out another 2, this became a 2 plus 4 cosine of 2x plus 1 plus cosine of 4x. So this step right here is factoring out the 1/2. That's the parentheses. I combined the 1 and the 2, and I got 3 there. Okay, and that's where that term came from. Okay, so this one was a little bit more in depth. Hopefully you understand it. Look at the maths. Stop the video if you have to. Make sure that you understand it. Here are some more problems. A couple pages to read on these formulas. Here's some more problems to give you some practice using the double angle and the power reducing formulas. Again, just know that they're there, know how to use them, practice using them, and then if you have any questions, make sure that you're emailing me so that we can get those squared away. Okay, fellas, a few more of these short videos, and then we have to do just law of cosines and law of sines, and we'll be done for the week. All right, have a good day.